said, I am Sri Kamani, working as a technical manager in Object Automation System Solution Private Limited. It's an AI-based company. So, as you all know, this session is about enterprise AI with DB2. So, I'm sure you all will get to know about the basic insights of IBM Db2, and also I'll take you through in the machine learning capabilities in Db2. So, before getting into detail about Db2, we'll see why we are talking about machine learning as a part of Db2, which is an IBM database product. So, as you all see this number, this is a survey report generated by a data science community. So, it's quite clear that around 66% of the data is from enterprises. So, this is a 2017 report. I think this would have got increased as of now. So it means most of the data is from business organizations. So we have a lot of opportunities. Since all the data are from business organizations, we are talking about this enterprise AI, and we have a lot of opportunities to partnership as a database product with enterprises and the enterprise data science team to work with machine learning environments. So before talking about what IBM Db2 is, first let's have a quick look on what the front end, that is what artificial intelligence is. So you all know about you all heard about artificial intelligence, right? So AI can amplify human capabilities and understanding. So this helps like transforming the huge data collections, which is growing bigger all the time. So this data collections into values, insights, and actions. Okay, so if I'm going to create a system which has the capability for taking a decision by its own, or if I'm going to create a system which can identify an object, or a system which can recognize human language or speech, so all the systems comes under the roof of artificial intelligence. Okay, so the next question will be like, how this system is created, how this intelligence system is created. Okay, so for that part, we have machine learning and deep learning approaches. So when you're going to create an artificial intelligence system, so we'll be moving on to this deep learning and machine learning approaches to work on that. So machine learning uses algorithms. So computers can learn from those with the help of those algorithms and the data which we are providing to the algorithms. A system can learn about the data and it can work according to that. Okay, so if you are going to work with the normal mathematical algorithms or scientific algorithms, in that case you will be making the system with machine learning model. And if you are going to create an algorithm as of how a human brain works, that is called a neural network. That type of algorithms, if you are going to build your model, if you are going to use and build your model, then you will be coming under the deep learning approach. Okay, so this is what artificial intelligence and the details about artificial intelligence, machine learning, and deep learning is. So I have explained what is the relationship between artificial intelligence, machine learning, and deep learning. So the next picture is about a traditional workflow, a typical workflow of machine learning development in enterprises. So when you have a look over here, the flow starts from this part, that is where the data is. So the data is stored in the databases such as IBM Db2. So if a data scientist who's responsible for all these things will take the sample data from the data repository, and he'll put that into his development system and do all his data cleaning and wrangling details. So once it is done, you will be getting a structured data. So this structured data is split into two categories called training and testing. Then they will try doing different data pre-processing steps, hyperparameter tuning, future engineering, and PCCAs, and they'll try different algorithms on it, and they'll come out with the exact model for their workflow. So this whole process is model development phase. So when you're going to work in this development phase, you'll face many challenges while working on it. So the major challenges they'll phase when they're in development phases. The first one is regulated data. So regulated data is nothing but the sensitive data. So if you are going to take these samples from these sensitive data, you should be very careful in handling with those data. Okay, so this sensitive data are under some regulations like GDPR, CPRA, etc. So if you are going to copy this data for your work, you should be very much concentrate on its confidentiality. And the next challenge what you will face is data volume. So whenever you're working with data, the volume of the data at present, if you are learning or if you are doing some process, if you are trying to do some process, means you will be managing data in gigabytes. Okay, so but this is not considered as a big data. So if you are going to work in a real life environment, you have to deal with the big data. So this big data comprises of hundreds and hundreds of terabytes of data. So this is at another challenge that how can a data scientist with the limited resources? So the resources plays an important role over here. So with the limited resources, how he can deal with this large volume of data in his model building. And the next challenge what he will face is noisy data. Okay, so according to an American survey, 25% of the data what we are using for model building is noisy data. So if you are going to inherit this noisy data in your model building, then it's damn sure that it will break the quality of the model. So these are the main challenges faced under the development flow. Okay. And when you're going to talk about the deployment flow, so once after solving all the challenges in our development state, at some point of time we have a decent model with a good accuracy. Okay, so now we'll try to deploy those models. So we are about to face the next set of challenges in our deployment stage. So that is where we are going to integrate our model for user consumption. Okay, so the first challenges what you are going to face is hosting, where you are going to host the model for user consumption. And the next is the speed. So suppose your data is in one location and your model is working in another location. So every time when an inference is done, your data has to be taken from your database to the model location, and you have to get your predictions. This could create a network latency. Okay, and the third one is like how you are going to integrate your model for easy prediction. So as of a survey, like 51% of AI models doesn't go beyond experiments because of these major challenges what they face in the deployment stage. So now how can IBM Db2 help a data scientist to address all these challenges? Okay, so when you're talking about this IBM Db2, it works under the philosophy called in-database machine learning. So what's called in-database machine learning? There's nothing but keeping the code near the data to reduce your latency. Okay, so keeping the code near the data is necessary to keep the latency low. So IBM Db2 warehouse includes a wide set of in-database SQL analytics. So that includes some basic machine learning functionality too, and also it supports in-database support for R and Python languages. Okay, so that is why we are concentrating more on IBM Db2. So this is a use case for in-database scoring. So the first one is latency sensitive decision. So what is latency sensitive decision? Suppose if I'm going to create a model for payment processing or fraud detection or a loan claim pre-approval. So when you're going to work with payment processing, people will try to pay by using the cards, right? So when you're going to access the card, the data, if you're going to try to classify whether the card is fraud or not, or the data is proper or not, that type of thing activities. When a person is swiping a card, the data has to pass to the machine learning model and it has to get checked over there, and the result should be popped out as soon as possible. So this should be an instantaneous predictions, right? So your data should be latency sensitive. Okay, and the next thing is large batch predictions. So if you are going to work with large volume of data, for instance, such as anomaly detection, for example, if we have to come across several set of analysis, if you are going to work with anomaly detection, so moving data every time to another system to get the prediction is very expensive and it leads to slow process. So this kind of use cases will get benefit from scoring inference in IBM Db2 databases. Okay. So now I'm going to give you an insight about how IBM Db2 helps a data science practitioner in addressing all the challenges, the above mentioned all the challenges in development and deployment stages to get a better solutions. Okay, so in this we are going to learn about two different solutions that deal with some of these challenges. So one is, the first is to integrate the open source models with Db2. So we have several open source frameworks. If you are going to work, if you all are familiar with the ML and DL part, you will be familiar with the open source frameworks like sklearn, PyTorch, TensorFlow, Keras, etc. And these frameworks, these open source frameworks have rich ecosystems to build the machine learning model. And the second solution is to build your entire machine learning pipeline inside Db2. So without moving your data outside the database, we are going to work inside the Db2 database itself, and we are going to build our own model. So we have some frameworks given by IBM Db2. So with that framework, we'll be building our own model. So these are the two approaches we'll be following if we are going to build an AI lifecycle in IBM Db2. So the first is, we'll discuss about the first solution, like bringing your open source models to Db2. Okay. So when you're going to talk about this open source model, IBM Db2 is having a solution called Python UDF. Okay. So what is this Python UDF? So if you are going to work in open source community like IBM Watson or your Jupyter Notebook, your sklearn framework or TensorFlow, whatever it is, you will be developing, you will be using all these frameworks and the functions or the libraries inside this frameworks, and you will be developing a machine learning pipeline. So this machine learning pipeline will be stored as a executable file or a model with the help of a joblet. Okay. So what this Python UDF will do is, it will push this joblib into the Db2 server. So by using a user-defined function. So with the help of this user-defined function, you can do inference inside your database itself. So it's not necessary you have to take the data outside and you have to get the inference. So within the data server, within the database, you can do the inference by using this Python UDF with whatever the model you have created by your open source libraries. Okay. So how this model is inferenced? If I'm going to create a open source library based model, how this is inferenced in your database server? You have the client application and the request, that is the inference request, will be sent into the database by using the SQL statement. So there you have your model file, so which has the train model and the data. You have the model executable file. So with that help of this executable file, you will be getting your predictions inside your Db2 server. So this will, the benefits of this will be your ML infrastructure, your low latency, because taking your data outside and doing inference and then again putting the data inside will increase your latency. So here, if you are going to work with this Python UDF, it will reduce your latency and you have high throughput and very simple integration with the help of your Python UDF user-defined function. Okay. And the second solution is like build and deploying models inside Db2. So without using the open source framework, how can I build and deploy models inside Db2? So for that, IBM released the Db2 version 11.5.4 with all the machine learning capabilities inside it. Okay, so you have a framework called IDAX framework. So in that framework, you have all the necessary libraries. So if you have to go with data explorations, you can go with the summary of statistics. You can have libraries to virtualize your data frames, to do your feature selection, and to your data frame operations. And if you want to go with the pre-processing steps for data pre-processing, the details what you can do is missing values, that is finding all the missing values, and normalizing your data, and standardizing your data, discretion, and train test split. So once after this exploration and processing is done, if you want to create a model, you have algorithms for decision trees, navy Bayes, linear regressions, k-means, and association trees. Okay, so you can do all your supervised and unsupervised approaches using these algorithms. So for the model evaluations, once after the model is done, you want to go with the evaluation process, you can use confusion matrix functions to find, and the accuracy, to find the accuracy you can use the accuracy function, and the precision, recall, and for working on regression you can work with MSE and MA. So these are the evaluation functions available in the IDAX library. So if you want to go with model deployment, either you can go with in Db2 prediction, or you can go with Python UD. So in either way, you can do your inference. So the main advantage is it increases your speed. You have your SQL interface on that, and you have distributed training. So if you have if your data set is distributed in many ways, if you are going to approach an algorithm or like a decision trees, it will work on all the distributions and it come out of the final solution. So distributed training is possible, and you have a good security and scalability. So this is what the features provided by DB2 in the version of 11.4, which has the ML capabilities in that. So by using this, we can do our in-database AI training. Okay. So once after all this, what are the challenges you face with normal ML or DL AI model building, and what is the benefits of ML with DB2? So if you have talent gap, so SQL interface, you have SQL interface for ML deployment. So if you are going to work with sensitive data, you have virtualized data access and model building in this DB2. And if you are going to go, if you have a data transfer cost, so in DB2 you have this in database ML, you have no data transfer. So for infrastructure, if you have lack in infrastructure, you have a secure and scalable DB2 infrastructure over that. So in the part of inference performance, in DB2 scoring of DB2 native and open source models. So you can work in either way. You can go with the native libraries, or you can go work with the open source models. So and then integrations of ML. If you are lacking integrations of integrating the model, then you have SQL based interface queries in DB2. Okay. So these are the important challenges and the benefits available in IBM Db2. So we'll go with the demo now. Like I've taken a demo, I've taken a data set of predicting used car prices. So this predicting used car prices is nothing but determining whether the listed price of a used car is a challenging. The model is going to predict the price of the used cars. Okay. So we have many factors working for this. We have many factors to work on this. So the focus of this project is developing machine learning models that can accurately predict the price of the used car based on its features. So what I'm going to do for this model building is I'm just going to connect to an IBM Power9 system called VINA system in University of Oregon. Okay, so in that I'll be using the necessary libraries where I can create a connection for the DB2 databases, and I'll be building my model by using this connections, and I'll be testing my accuracy there. Okay, so I'll stop this presentation with this and I'll go to the demo now. So this is the app which I'm going to use to connect to my system. So I have my system on University of Oregon. So I'll be connecting to that system. So you can see the details over here. So I'm going to SSH with authors.nic.oregon edu. So this is my username OA user. So with the help of this, I'm connecting to the system. So this is the gateway. So from here, I'm connecting to the Veena system. So I've connected to my Veena system. So if you want to know some details about the architecture of this system, so this is the architecture of the system. So the system name is Veena. So it's the OS is Ubuntu, that is Linux based OS. And if you want to know about the processor information, you can get the process information that it has 176 cores. It's a Power 9 processor with 176 cores. Okay, so this is what the processor information. And if you want to know about the memory information about this, so you have around 224 GB of memory. Okay, so I'm going to use this system to develop my model. So from here, I'm just going to connect to the Jupyter notebook. So for that, first I'm just activating my Conda environment. So it's as activated. Now I'm going to create my own environment for my DB2 development. So in this environment, I have all the libraries which is used for my model development for this IBM Db2. Okay. So I've stepped into that environment. Now I'm going to open the Jupyter notebook. So my Jupyter notebook got activated. So to work on this, I have to open another tunnel. Now I'm connecting that to the Veena system. So this is the Jupyter notebook I've opened in my local browser. So I've connected to the Veena system and I opened the Jupyter notebook in my local browser. Okay. So this is the notebook environment. So if you're been to the ML and DL development, you would have known about this environment. So here I'm going to present you a model for this. Predicting the used car prices. So this data set I have taken from the website called Kaggle. Okay, so it's a car price prediction data set. So you have features like present price, that is the present price of the car, the selling price, the kilometers driven, the fuel type, and the year, and the car details, etc. So using these features, I'm going to predict the selling price of the used car. Okay. So for this, first what I'm doing is I'm just importing the necessary libraries needed for your model building. So once after importing all the necessary libraries, I just go with the IBM libraries, which is used for my connection. So, okay, so the two important libraries you have to focus on is this IBM underscore DB and IBM underscore DB underscore DBI. So this two libraries is necessary for your connection purpose. So here I have just created all my connection details, like how I'm going to connect to the database. So with the help of this details only, your system will connect to the IBM Db2 database, which is there in the VINA system. Okay, so this is my connection string. So first, with the help of IBM DB, I'm creating the connection to the database. So once the connection is created, I'm just getting that connection into my Jupyter notebook with the help of this library IBM underscore DB underscore DBR. Okay, so that's why these two libraries are important. So once after the connection is set, what I'm doing is I'm just using an SQL statement to retrieve the data from my data set. Okay, so the data set is car data. So it is there in the instance called INSMPD. So I'm getting into that instance and I'm taking that details from the car data by using this select statement, and I'm storing it in a variable called SQL. So this is how you'll be retrieving the data from your database into your working environment. Okay, so then you have to go with the read SQL statement to create your data frame. So this is my data frame. So you can see all the details like ID, year, selling price, present price, what are the features available in your data set is listed over here. Okay, so once after the details is done, I'll be going with the pre-processing steps. So I'll done with the information. So that is what are all the details available in your that is structure of your data set. So this is what the information I have received. Then I'm just going with the statistical information. So here I'm taking all the statistical information without excluding any of the columns. So I'm taking all the statistical information. So then I'm doing some pre-processing steps over here. So finding the null values and all. Next, once after, since I don't have any null values, so it's not needed to treat the missing values. So the next thing what I'm doing is feature extraction. I'm just going to check what changes I can do with the available features. So instead of here, I'm just changing the car age by calculating it from the present year to the year given in the data set, and I am calculating the car age. So this car age is enough for me instead of having the year. So I'm just doing the feature extraction over here. Then after that, I'm just doing some exploration and visualization by comparing the selling price with the other details. Okay. So and I have got some observations over here. So the next thing is the same thing like other things. We have got some, what are the observations? All the observations is based on the selling price only. So once after the visualization is done, we are going to check with the categorical variables. Okay, so we have several categorical variables in our data set. One is fuel type, seller type, transmission, and car type. So we have to deal with this categorical variables, and I'm just going to drop this car name because we have several categories in that, so it's not going to help for my model building. So I'm dropping that car name. So once after the car name is dropped, the rest of the things I'm just doing the data encode. Okay, so I'm just doing data encoding over here where I'm converting the categorical variables into numerical values. So once after that, I'm just checking for the multicollinearity. So once multicollinearity is checked, we got that we have collinearity between kilometers and kilometer driven and fuel type petrol. So we are dropping that columns, and then we are going for the correlation mapping. So once after correlation mapping is done, we are just going to take the values, like which are all the features are important for my prediction. So this particular detail will give you a detailed insight about the features necessary for your model prediction. So here I can see the owner is not that important, so I'm just dropping that owner column. With the help of the rest of the features, I'm just going to create the model. Okay. So for model development, the first step what I have to do is I have to segregate the model into independent data and dependent data. So once it is done, I'm just doing the scaling. So I have to scale all the details in one particular order. So I'm just doing the scaling over here. So once scaling is done for the trading data, so once scaling is done, I'm just going to work with the test, train and test split. So I'm splitting the data to here. So once after the splitting is done, I'm just building my linear regression model. So linear regression, I have done the linear regression model building, and the accuracy of my model, what I have received is 84%. So it's a quite decent accuracy. So once after the model is built, the next thing what you have to do is you have to dump your model. So you have to store your model in some way. So I'm just using this pickle library, and I'm just dumping my model in a name called LR model. So this thing you can use for your Python UDF creation. So you have to create a UDF function where you're going to use this particular executable format, and with the help of this particular saved file only, you can go with your inference. Okay. So for as of now, I have created a UDF over here. So I have written a function. So where I'm going to pass the necessary features. So with the help of the new features, I'm doing all the scaling and all, and I'm going with the predictions. So this LR predict is what model I have prepared. So I'm just going to do with this prediction. So here I'm just calling the function, and I'm pushing out some values into it. So now you can see the selling price what I have received is around 10 lakhs. So for this particular feature, my model has predict the cost for the car is 10 lakhs. So in the way for some other data, I can receive it's 9 lakhs around. So this is what your model building is. So this is how we are going to integrate your database by using your connection string with your open source environment.
What did you understand from this demo?
Yeah, well, sir, in this demo, I understand using a sklearn and to do the supervised linear regression model, and it will predict the car price.
Because this particular setup is very important, because most of the enterprises, as I said, in with you all, enterprises uses this DB2 kind of a powerful database and the power system, which has been prominent, among enterprise customers. And we have a Linux there. We also can have a AIX kind of an operating system too, with all kinds of the features you learn with ML, with the machine learning. It's not just this use case, but you can develop hundreds of use case. You can enable many existing the use cases with ML deployed.
You can visit the IBM website to get more knowledge about this in database machine learning concept.
Very
like
good.
How they can go once they are familiar with this basic ML details, they can get into the IDAX framework and they can build their own. The main thing is they should know some basic knowledge in SQL. Another advantage is you have this DB2 and this infra over there in the cloud. You can use IBM Watson and you can integrate with the cloud DB2 and you can develop your own model. So that is the main advantage why we are going for this IBM Db2 for this enterprise.
Yep, that's correct.